My name is Waleed, and I'm going to be describing to you the features of your Freedom 24 and how to set it up. The Freedom 24 is a dry electrode system that has 21 sensors that will not require any gel or skin abrasion. I have a sample of the sensors in my hand. You will see that there are pins on them to go through the hair, and some of them have foam around them for comfort. We'll be introducing the headset in a little bit. First, a question people always ask is dry electrodes. How do they work? Why is it that your dry electrodes work so well? So there isn't a single answer to this. Dry electrodes have been developed since the 70s, and people have often complained about high levels of noise, motion artifact, discomfort. We had to address all of those. So we've had about $20 million in R&D funding to develop these sensor technologies. This funding came from sources such as NIH, NSF, DARPA, Department of Defense. The mission was to develop high-quality EEG sensors that did not require any skin abrasion and any gel. And the reason for it was to develop EEG that could be done in a more real-world setting than current EEG, which required skin abrasion and gel. So we started off the development process with our electrodes, which were initially designed for measuring low electrical signals in high noise environments, and we modified their shape. So the electrodes have pins to go through the hair, and I do not have any hair, but that would allow them to manipulate and move through the hair. We have ultra-high impedance amplifiers in there, and those allow us to amplify the signals that are the very small EEG signals. What we immediately had to do was also provide the levels of shielding to protect us from the high noise in the environment. When you have a non-gelled and non-skin abrasion contact, we have contact impedances that are on the order of 100 kilo ohms to 1,000 kilo ohms, as opposed to a wet electrode contact, which is typically 5 to 10 kilo ohms. So we are going to be susceptible to a large amount of noise and artifacts from the environment. We deal with those by providing a layer of shielding. So the outer layer of this electrode, the outer ring, is a Faraday cage. Each sensor has a Faraday cage. That provides protection from the electrical artifacts in the environment. We also have active and passive shielding inside the sensor and inside the system that are patented and protected, but also do an excellent job of protecting and eliminating some of those artifacts without requiring any additional filtering. So once we had good signal quality, we demonstrated that the signal quality we get is the same as the signal quality that's obtained from a wet EEG system, conventional medical grade EEG system. Then the challenge was, all right, how do we deal with positioning the system? How do we get the electrodes to sit on the head and be comfortable and be at locations that make sense? So we developed a headset that was designed to position 21 sensors on the head. There are 19 sensors in the 1020 montage, and those are the sensors that are there. In addition, there are 2 ear clip sensors for referencing. So we'll be demonstrating how to don this headset. But as you can see, the headset has a lot of moving parts, a lot of mechanical adjustments. Those were designed for 2 purposes. 1 is comfort, and 2 is easy adjustment and positioning of the sensors at the proper 1020 locations. Different people have different head shapes, and so there are different adjustments that allow us to deal with different head sizes and head shapes. There's a band that we can tighten and loosen. There are adjustment sliders that move sensors and the entire system, and there are mechanical moving articulated pieces that allow for smooth adjustment onto the head and comfortable positioning. So we'll be demonstrating how we put this headset on in a few minutes. So once we developed the headset, then the next thing was to validate how well it works in a real-world environment and how well we can deal with artifacts. And we'll be demonstrating some of those capabilities of dealing with motion artifacts and electrical artifacts through our patented double spring loading mechanisms. Next, I will be describing the common mode follower technology. One of these sensors is our active reference. We refer to it as a common mode follower. That is a very unique and patent technology that we have developed that allows us to deal with the motion artifacts and electrical artifacts from the environment. It is a very wide input sensor that works in the background to eliminate electrical artifacts from your signals. And when we show you the signals in the next round, we will show you how to compare the signals with and without the COM mode artifact. And all of this happens transparently for you without any effort. Head circumference 55.5. Okay, Valerie, can you turn please so that you can get a side view? And we're going to create that part right above there. Perfect. Sure, thank you. You've grown more hair than usual. Thank you. Bring it down, open the back arms to help it slide down, slide it all the way to the ears. Stand in front of the subject, rotate it so that the arrow is centered on the nose. Take your lovely tool, move the hair out of the way. Out of the way. Tighten slightly, adjust the headset down, tighten slightly, tighten slightly. In case of long hair, we're going to be parting the hair. So we'll have close-ups of those later. You don't have to be perfect here in moving all the hair. You're just trying to create bundles of hair between the sensors rather than under the sensor. You do have to push the sensor all the way out. All the way into its home in order to be able to move this hair out of the way. Sorry, Val. Okay, once that's complete, we can tighten the headset all the way. How's that for comfort?
It's good.
It's good. Val, can you turn around 90 degrees? We want the headset to be flat. And now we will start to work the sensor through the hair. So I'm going to part. Drop it down. Take the tool. Rotate. Press down. I feel like I'm forgetting to do something. What am I forgetting, Val?
Ear holes.
Oh, ear holes. Thank you. I knew I was forgetting something. So we want to adjust this hole to be right above the ear hole. And it's at the 3 mark here. It's at the 3 mark on that side. And then we want to adjust front to back distances. So it's already centered. And left to right, it's not centered. So we're just going to slide it. Now I can tighten these guys a little bit. Okay, that's good. Thank you, Val. So again, I'm parting the hair underneath the electrodes. And we do the rotation. The rotation is all the way to the left, all the way to the right, bring it to the middle, press cha-cha-cha, press down. Go over that in detail later. And yes, we do this to every sensor on the head. And don't forget there's one on top. We do not apply any pressure while turning on that one. It's a very sensitive location. Okay, and then there's one more here. The subject usually will feel and be able to tell you when the sensor is touching their skin. But with practice, you will also be able to feel that yourselves. Okay, and the next step is to attach the ear clips. I'll do this one next. I'll show this one first. And the earlobe is stretchable, so you can stretch the earlobe and attach it. You put the sensor on the back side of the ear. Oops. Sorry, Val, I know you don't like it behind the ear. I'll put this one up for you. Okay, and what else am I forgetting? Now we can tighten the last tightening if needed. And usually we would do that if we're going to walk. Then we should have turned it on before. Okay, so that's the donning process. So we're going to go through the process of donning the headset and all its intricate steps. First thing we're going to do is measure the circumference of the head. We're going to do that at approximately midway in the forehead, which is where the band is going to be. We do not need to be exactly accurate because all we're trying to do is determine whether the headset is in range or not. So the tape measure provided has a 0 point. I'll put that in the center of the forehead. I'll go around the head and be sure that I'm horizontal, and then I can read her circumference. So Val, if you can rotate your chair, please. You want to be above the inion. You want the circumference to be horizontal to the floor. You don't want to be sliding up. So if you turn back around, please. So Val's circumference is 57 when measured at the right height. Last time I measured it was a little bit too low. That's the measurement. So is she in range or not? The range of the headset is designed for 54 to 62 centimeters in circumference optimally. It can go down to 52 centimeters. At the lower head sizes, the contacts at F7 and F8, those locations right there and those locations back here will become looser, so they will be less able to go around and ambulate, walk freely. You just need to be more careful in adjusting the headset. Once we know that the subject is in range, we can loosen the headset, pre-loosen the headset to approximately that size. So I can release the bike lock mechanism and pull the band out to the approximate size that's needed. I will leave the bike lock unlocked at the time of donning. I will hold it by putting my fingers underneath the headband, and I will expand it to make sure that this piece is not, this upper arm piece is not on top of the band as shown right now. So I'm going to loosen it like so on both sides, so that I do not have to deal with the head doing that effort for me. So I'm opening it, and with my two fingers I'm going to hold the band, so I'm supporting the band so it doesn't fall into the subject's eyes. And for long-haired subjects, there's a pre-step that we will do, which is we are going to part the hair above the ears. So Val will rotate, and what I want to do is create a part right along the midline to find where her ear is. And I'm sending half her hair to in front of the ear and half her hair to behind the ear. I don't have to be exact about it. We'll do that on both sides. Thank you. The purpose of this is there's going to be a sensor right there, and we'll want to reduce the amount of hair that that sensor has to deal with. Okay, the next thing is to make sure that you have batteries inside your headset. You don't need 2 batteries, 1 battery is sufficient. They're hot swappable. And then we'll turn the headset on. To turn the headset on, we recommend you support it somehow by holding the top piece with one hand and press the power button twice. Once, twice. It will go through a sequence of flickers, and then it will flicker the status light to indicate that it is ready to operate. Now, we'll go back to holding it. Val, if you can turn 90 degrees. Thank you. That's fine. I'm going to position it. I'm going to be standing somewhat behind the subject. I'd like to keep an eye on the subject's face so that I can see if they're wincing or smiling or grinding their teeth in pain. They should not feel any pain. I'm going to lower the headband down towards the ears. And before I get all the way there, I will feel friction with those 3. And you may have to open them up a little bit so that the headset slides smoothly down. Okay, and I want to make sure the headset is above the ear, and it can press down on the ear if people have large ears like myself to have this Dumbo effect, but do not put the headset on top of the ears, which would be very painful. This is comfortable. At this point, we are going to slightly tighten the headset to make sure it's not falling down on her, which in her case it's fine. And then we're going to adjust those sensors because they're sitting at an angle and they're not flush on the head. So all the pressure is coming down on 1 or 2 pins on the head. That could be uncomfortable. So we're just going to put 2 fingers on each sensor to make sure that they are flush on the head. So that while I'm adjusting the headset, the person isn't sitting there with 2 pins poking at their head. Okay, next we're going to center the front arrow. By centering the front arrow, the entire headset is going to get centered on the face. So right now the arrow is too far to the right of the subject, and I'm going to slide it to the center. There's some hairs also in the way, so I'm going to move those hairs. Okay, so to remove the hairs, I'm going to use a Q-tip or a stick. And I'm going to lift the headband. That's why it's still loose right now. We haven't tightened it completely. Oops, sorry, Val. And Val, can you lean forward, please, a little bit for the camera? And I can bend the front strap so that I can see the electrode tips and make sure that there are no hairs underneath them. And I can do that on both sides. Some people have hair growth at this location, and that's okay. There are pins under these sensors. Oh, there's only a few more here. Sorry, Val.
You can leave them.
I can leave them?
They're fine.
Okay. All right, so we move the hair out of the way, and now we're going to adjust the arrow. To adjust the arrow, I'm going to hold the headset from the plastic pieces. Can you rotate a little bit, please?
Which way?
This way. So I'm going to hold it from this solid plastic piece. If I hold it from here, this piece slides, so that's not very helpful. So I'm going to hold it from this piece right there on both sides. And I'm going to ask the subject to resist. Now you can face the camera, please. To resist, and I'm going to, you typically stand in front of the subject and rotate the entire headset so that it's properly positioned. I want the headband to be about a centimeter above the eyebrows to be clear of that soft tissue area we talked about earlier, which if the headband is on it, it will cause headaches. So this is a good place for the headband, and now we're centered. Okay, so the next step is to bundle the hair. So we'll use either the Q-stick or the tool, depending on your preference, and that's only for subjects with long hair. You do not need to do this for subjects with short hair. The way the bundling works is for each of the sensors, I'm going to retract the sensor in. Each of the sensors in the band are designed like this sensor right here. What I'm going to be doing is with one finger pressing down the entire electrode into behind the foam so that I can come down with the tool and slide the hair out of the way. And then I release it. If you don't move it sufficiently, the pins will be blocking you and you will not be able to move the hair out of the way. So you need to push it in all the way. Now you can part the hair easily. So at this point, I'm going to come in underneath the sensor pod, and from the top side, I'm going to move the hair out of the way. The objective here is to create bundles of hair between the sensors and not under the sensors. You do not need to do this on subjects with long hair. You actually, with hair such as our subject over here, we do not need to do this. I'm showing you how to do this for cases where the hair is really, really thick and bushy, such as myself. So we go around and do that to each of the sensors. Sometimes you might find it's easier to reach from the bottom of the headset, and sometimes you find it's easier to reach from the top. It doesn't matter. Okay. Okay, so the next step is to brush away the hair from underneath the front strap, which we already took care of that, and I'm just going to verify that nothing has moved back in. Again, I can bend the front strap out and I can see very clearly that there's no hair underneath the electrodes. At this point, I'm going to tighten the headband. Now this step is the most things are happening at the same time in this one step. So we're going to turn the Valerie so I can show what I'm going to try to do. I'm going to put one hand in front of this forehead. I try to put these fingers so I'm not blocking her face like that. So put one hand here to support her head because I'm going to be tightening the headband. Right now the headset is inclined too low on her head. Often people tend to do that. It's too far back. We need the sensors to be above the inion. So that means that these sensors need to be above the inion. The way to ensure that is to make this headset flat to the ground. To exaggerate this so you can see it clearly, we're asking Valerie to sit really straight and lower your head a little bit, please. Okay, so now her head is really horizontal, and now I can see how much I need to adjust this. So in this case, I'm just going to lift it up to this much. Now you don't want to lift it up like this. You want it to be flat like that. So you're lifting and holding it down. So now you've got a parallel to the ground level. Now I'm putting one hand here, and while holding it in place, I'm clicking the knob and turning it. And then you can ensure that it's not sliding up, tighten, and ask the subject how that feels. How does that feel?
Good.
Okay. Next step, adjusting the T3, T4 sensors. So this is the T3, and on the other side is T4, and we need the center of that sensor, the hole, to be above the ear hole. And so there's a slider over here, and we can slide it forward or back. This would be too far back. This looks about right. And if you turn around, Valerie, please. Thank you. Again, we can do the same adjustment over here. That is not only going to move the sensor, but it will preset the position of how the stop hub will move. So the next step is for us to adjust the stop hub. So the first thing I will do is align that little arrow to this arrow over here. And right now they are pointing to each other. So there's an arrow right here that's difficult for the camera probably to see. And there's an arrow right there. So those are pointing to each other. And the next thing I'm going to do is adjust the distance between the top band and the bottom of the sensor by putting my fingers there. And Val, if you can turn around, please. Thank you. Yeah, perfect. And the top of this band and the bottom of the sensor. And right now I have room for one finger here and two fingers there. And this headset isn't going down yet on her head. So I'm going to push it all the way down. And if it wants to ride up, we'll use this elastic band right here with the cord lock, tighten it a little bit. So remember, we'll pull it out, squeeze the cord lock, release, and we'll hold it. If you can turn around, please. We'll pull it out, slide the cord lock down. This has a kind of, it's coiled back in, so you just need to make sure you're pulling the side. The way the cord works, it loops up. So when you pull it from one side, you're essentially tightening both of these arms down, and that will hold this guy from wanting to slide back up. Now I can go back to my adjustment, and I have one finger plus a little bit more, so I'm going to slide it. So I hold it from the top hub, and I can slide it forward. Now I have one finger on both sides, and they're equidistant. Now I'm going to do the same thing for this sensor on both sides, and in Valerie's head, they're pretty close to touching on this side, and it's pretty close to touching on that side. So I could just put my fingers there and see that it's equidistant. If it wasn't, I would just hold it and slide it as needed. You can typically do this step all at one shot. You can just adjust it all in one step. At this point, we could tighten the elastic band some more if needed. How do you know how tight it needs to be? It's a trade-off between comfort and stiffness. If your subject is going to be standing around and ambulating, then you will want it to be really tight. If your subject is going to be sitting down, it just needs to be tight enough that it's not wobbling when you press down on the headset. Okay, if you're not sure, when you look at the signal quality, you'll be able to see if when they move, you're seeing artifacts, and then you can just tighten some more. On long-haired subjects, I tend to over-tighten the band at the beginning, because if I don't, as I'm manipulating, it will just slide, the entire headset will come out. And at the end of the donning, I'll ask the subject, how does it feel? Can you handle wearing this for an hour or two? And if they say yes, then I'm fine. If not, then we can release and push it back in. And that will release the pressure. And if it's too loose, then you can tighten back up and find the soft spot, the correct location. So this next step, we're going to be rotating the sensor to manipulate the pins through the hair. On the back side of the sensor, there's a square hole into which the tool fits, and then we will rotate it. The way it works is we will rotate it one side all the way till it stops to the right, and we'll rotate it all the way back to the left, all the way back to the right, all the way back to the left. Then we bring it to the middle point where we'll have the most range. And now we'll give it a cha-cha-cha, so it's a few rapid wiggles. You have to imagine the hair sitting right there. The first long manipulations move us slowly through the hair. The last few cha-cha-chas, they're just going to allow any remaining hair follicles to fall in place. And at the end of that process, we will gently press down on the sensor. So we will start with the CZ sensor. I'm going to put the tool in, and I'm not applying any pressure during the rotation, very slight. So left, right, bring it to the center, cha-cha-cha, press down gently at the end, pull it out. Next, I'm going to do this PZ sensor. I'm going to lift it up, part the hair. I only need to do that in cases of long-haired subjects. Put it down. I'm going to take my two fingers, put them on the back side of the sensor, make sure the sensor is flush on the head. So that means left, right, up, down, in all directions. Sensors can be inclined. They have a lot of degrees of freedom. Want to make sure they're flush against the head to make sure all the pins are touching. I'm going to leave my two fingers to support, put the tool in, left, right, bring it to the middle, cha-cha-cha, press down gently, release. I'm leaving my fingers in place so that the sensor doesn't come out when I'm removing the tool. How does this look in real speed? Lift up, part, put it back down, left, right, cha-cha-cha, press down, release. And we do this to all the sensor locations. Lift up, part the hair, drop it, left, right, cha-cha-cha, press down, release. Lift up, part the hair, put it down, left, right, cha-cha-cha, press down, release. Left, right, cha-cha-cha, press down, release. At this point, if you are training subjects and customers, it is very good to let them do the rest of them, so that the subject can inform them if they're pressing too much, too little, if they're doing the same manipulations as you are doing. And it's really good to allow each client or customer to have that done to them, even if it's just with the dummy sensor, so that they feel what this feels like. People are sometimes very, very gentle or delicate when they're rotating, and they're afraid that it's going to hurt the person. It's really a very comfortable and almost enjoyable process of getting the sensors through the hair. On the sensors that are on the band, your fingers don't do anything, so there's no need to put your fingers here. Instead, I recommend you put your hand on the other side of the head to support the head as you are pressing down on the sensor. Now you'll also notice here I'm not counting necessarily 1, 2, 1, 2. There's a lot more hair. 1, 2, 1, 2 in this case is not sufficient, so I'll do a few more. And you will be able to feel the hair reduce its friction, and then I can do the cha-cha-cha. And they can see the hand is applied. Okay, next step, ear clips. The earlobe is stretchable. Here's the ear clip sensor, and the sensor is on the back, on the thicker side of the sensor. We want the sensor to be behind the earlobe, on the back side of the earlobe. That's because there's less hair growth and less wax buildup on there. You can also clean that the earlobe with an alcohol swab if deemed necessary for your particular subject. So you would wipe down the surface areas. Some subjects prefer to have the sensors placed on the cartilage part of the ear as opposed to the earlobe, and you can do that as well. So we will pull down the surface area to the earlobe to maximize the surface area that's in contact. Sorry about that, that's my fingernails. To maximize the surface area that's in contact with the sensor. So this is one. You can turn it around, please. And on this side, I will demonstrate placing it on the cartilage. Again, the large side of the sensor is on the back side, and you can apply it this way. The headset is designed to be extremely comfortable for long wear. At the end of the donning, you should ask your subject, does this headset feel comfortable enough for you to wear for 1 to 2 hours, depending on your recording period? Multiply that by 2. So if you're recording for 1 hour, say, is this comfortable for you? Can you imagine wearing this for 2 hours? And if the subject says yes, great. If the subject says, how does that feel?
A little pressure right here.
Most commonly, subjects will complain about pressure there. That will happen about 10% of the subjects. That's not their, that's due to different pressures between the sensors and the forehead and their curvature there. The way we deal with that is we have these inserts that we will apply at the end of the donning when you ask them how comfortable does it feel. And then we will release, so turn around, release the bike lock mechanism, and we will pull out the front strap. One way to pull out the front strap without damaging all the other hard work we've done is to put 2 fingers against the plastic and 2 fingers against the rubber on both sides. And I can pull the front band out. That gives me enough space to work. I can have you bend your head, please, towards the camera, this way. Then what I can do is I can pull all that slack to one side, take this Velcro, there's Velcro on one side, and I'm going to position it so that the hole is allowing the sensor to go through. And make sure the hair isn't in place. Then I can do that to the other side. Pull the band and adjust it. You really want to make sure that right now the electrode is being obstructed by the foam. So I need to adjust it so that the electrode is not obstructed by the foam. There we go. Move the hair out of the way. Then make sure that the arrow is still centered. How does that feel?
Good.
In case of recording in wired mode, we are going to use the provided USB cable to connect the headset to the computer. We will take the micro USB portion and we will plug it into the connector towards the front on the left side of the subject. So it goes right there. And then we have a strain relief point, if you can turn a little bit, Val, which is right there on the back side. There's one in the front for the back cable connector, but the one in the back is for the front. So you will loop the cable like so and connect into the strain relief. So that when you connect this to the computer, since the headset is so comfortable, subjects tend to forget that they're wearing a headset after a while. And should they stand up to go to the bathroom, they could end up yanking and destroying the connector. Instead, you have the strain relief. So if you were to tug on it, it's going to tug on the strain relief first, protecting the connector there. So once the headset is on, we can connect to the software, and once the software is streaming, one of the first things we're going to check for is the contact impedances. The contact impedances should be below 1 mega ohm ideally. You can get them to operate up to 2 mega ohms, but we recommend below 1 mega ohms. So we're going to take a look and see how we're doing. And so the sensors are here are arranged in a particular order. The frontal electrodes are on the top. So FP1, FP2, they're all pretty clean. It gets down to, can you move the mouse please? It's to 0.1, and that's about 1.1. So it's within range, but I'm just today, for today's purposes, going to demonstrate to you what would we do if all our signals were 0.2, 0.3, and one of them is 1.1. We can probably bring this one down. The first line of defense to bring that down is to just take the tool, put it into 0.1, so 0.1 is right back here, and just gently press down. Find the hole, press down gently, and pull it back out. Now it's going to get noisy like that. Do you guys have a software reset button?
It's already. We'll get it.
Do you have a reset button?
It's already reset.
How did you do that?
It does it on its own.
You have an automatic reset button now?
It does it on its own.
Okay, cool. I'll have to ask you about that. All right. So as you can see, so there's 0.1. It's not reset right now. It's saturating. It's 0 mega ohms. So what I'm going to do is I'm going to push the power button, which provides me a reset. And now we can see that our impedance is not 0 anymore, and there's a value of 0.3. So if the impedance is saturating, if the amplifier is saturating, it could look like signal. I'll demonstrate that to you guys in a second. But anyway, for right now, this was 1.2. I pressed it down. I took my finger off, and it went down to 0.3. Typically, you can drop it down by about 0.7 on average mega ohms. Okay, let's go down to the list. We get down to T5, and that's 4.9. That's much more than I'm going to be able to do by just pushing down. I'm going to try pushing down just to see what that does, but we're going to see that that's not going to do very much. So here's T5s on this side. And I'm going to put the tool through the hole, just like I did. I'm not rotating it, I'm just pushing down. And then we're going to push the power button to reset the amplifier. You can see when I push the power button, it has this very large artifact there on the screen. So brought it down to 1.2 something. So brought it down a little bit, but it's indicating to us when it was this high up that there's probably still some hair left in there. So we're going to put the tool in, and we're going to work it a few more times. And then I will push down again gently. I'll release, push the power button. And now T5 is just under 1 mega ohm. We're good to go. Next one, please. Can we scroll down? Okay, so all the remaining impedances are below 1. That's a good starting point. But that's not the only point. We then need to look at the signals and make sure that what we have are good, clean signals. So if we can scroll to the top, we'll start at the top. So we're looking for low noise on the EEG and low high frequency components. High frequency would indicate that there's some EMG tension there. So if I was asked Val to look up a little bit, you can sometimes see some increased EMG in her brows. So you ask the subject to look down about 10 feet in front of them on the floor, relax their face, and that will take down that high frequency elements that you were seeing on the frontal channels. The other thing you look for is blinks. You can ask the subject to blink a few times, please. And the blinks should be centered in the frontal channels. Here we've got F8 and F7 are down here. So those are also frontal channels. So we can see blinks in those correct channels. That's a good sign. We're seeing the right thing we're supposed to see. We're referenced here to linked ears. So we're going to scroll down to look at the remaining channels, see how they're doing. Okay, so I can see some artifacts on T5 and T6. I'm going to just make sure that Val is sitting straight with her head above her shoulders so that there's no muscles really acting really hard, working really hard to hold her neck in place. And we can see that that cleaned up T5 and T6 a little bit. Okay, if we can scroll down, I'm trying to look for, see if there's any other artifacts that we can eliminate. But that looks pretty good to me. Any comments? How does that look to everybody in the room? Looks okay. All right, now I'm going to ask the subject to close her eyes. So we can ask the subject to close her eyes, please. And Val does not generate a lot of alpha, so maybe we don't need to ask Val to close her eyes. We'll ask Val to bite down. So biting down will show you EMG. And so that's the high frequency components. About 80% of the people will show alpha when they close their eyes. About 20% of people will not show alpha, so don't hold that against them. This is a little bit of a smiling artifact. So the reason you do check for alpha is it's one of the EEG signals that you can get to produce and see visually. In this case, we won't be able to see it here. But we can look at the blinks and we can look at the jaw clenches. Okay, cut. Yes, please.
So what if you have a child who's...
Okay, so we're gonna do that in a second. Okay, great. We're gonna move into artifacts. So first I was just getting clean signal quality. Okay, so any questions about the clean signals, what clean signals should look like?
What about when you were saying that you can have them sitting down versus if they're standing and walking around?
Okay, we're going to do that along with artifacts. Great. Okay. The other two artifacts we're going to try to do is motion artifacts, which are dealing with those. We're going to try to see if we can get Val to sweat and get some sweat artifacts, or we can do that with somebody else. The one that she's not demonstrating right now is CBA, cardioballistic artifact, and I want to show you guys how we deal with them, even if we don't get them here. Okay.
Are we going to roll again?
Ready? Yep.
Okay, stand by. We're going to, even though you didn't shut this off, I want to resync it. Stand by. See where it says stop up top there? Circle stop. Circle it. Circle it. Just drop on the letter S. Good. Stand by. Okay, Wally, you're going to be looking at the camera?
Yes.
Stand by.
So now that we have demonstrated what good clean signals are going to look like, we're going to talk a little bit about some artifacts that we want to be avoiding. So one of the artifacts, there are several artifacts that you can expect in your environment. Some are electrical artifacts that are coming from 50 hertz or 60 hertz mains frequencies, or people walking around you in your environment. Our headset is designed to be immune to those. So when I walk around, we should not see any artifacts. I'm going to exaggerate this case by putting my hands up in the air next to Valerie and tapping my foot and generating a lot of electrostatic activity. And we should see, we're seeing it on one channel, which is F7, which is on this side, which is where I put the foam pad, which probably means that it's not making very good contact. So you should not be seeing any of those artifacts if you got everything sitting on correctly. So though your impedances are good, though everything is clean, that would mean that this sensor is going to be susceptible to electrical artifacts from the environment. And now, in reality, I'm injecting a lot more artifact than anything around you is likely to do to generate that. So just me walking around is not generating enough artifacts. But when I tap my foot, that's a huge amount of artifact that I'm injecting. We should not see it. So in this case, we would take out the foam pad, and that should get rid of it. Okay, so that's one test you can do at the end of your donning to check and see whether your headset is working correctly. The next thing we're going to test for is motion artifacts. So we're going to ask Valerie to stand up, please. And I'll take the paper and that. And we're just going to ask Valerie first to just move her hands freely. And maybe close your eyes while you're doing that. Okay, cut. So there seems to be a huge amount of delay because I'm still seeing blinks. Can you blink a few times, please, Valerie? Okay. So I guess those were just eye flutters that we were seeing.
Sorry.
That's okay. All right. So we'll repeat that because it was looking like there was movements.
So are we going to record again? Just let me know when.
Yeah, hold on. Valerie, can you move your arms, please? Yeah, okay. So there's nothing related to the arms. Those are just eye flutters that are happening just naturally, even though her eyes are closed. So go ahead and move your arms, please. Okay, and now move your head around casually. Okay, so those are EOGs. And on F7, F8, you're seeing EOGs. So just sway your body. Okay, and now we're going to ask you to walk, please. So when you do a walking test, you want the person to fixate at one point so their eyes aren't moving. So you ask the subject to fixate at one point and walk straight. So we can see, okay, yeah, we can see some artifacts on C4. So you can see those walking artifacts on C4. With every footstep she's making, there's an artifact. So what we're going to do is we're going to adjust that. And so you're taller than me, Val. I'm going to bring the chair back for you. Okay, so C4 is right there. And I'm going to, I can see that the headset is riding up on her head. I'm going to bring it down. Is that okay?
Mm-hmm.
So what I did is I just tightened the headset. I'm loosening it so that it's not pulling it back up. Is that too tight?
Mm-hmm.
Okay. Okay, now I will hit the reset button, which is the power button on the headset. Okay, so now you can see that we've messed up C4. So I'm going to adjust C4. And T3 is also out of range. And O2 has wiggled its way back out also. But O2 is only 1.2, so all I did was press down on it. Push the power button. Oh, good. We got...
So CBA
Yeah, good. So who can see the CBA artifact and tell me what channel it's on? Good. Can you guys all see that? So CBA is a rhythmic pulsations that are caused by the sensor sitting right on top of a blood vessel. So the way we're going to deal with that is I'm going to put the tool inside the sensor, which is at fault, which is F4, which is this one right here, and I'm going to translate it to one side or the other. So I'm going to slide it. And it has very little bit of mobility, so I'm going to move it about a millimeter, and I can adjust and press down. Anytime you manipulate a sensor, you push the power button to reset the amplifier. And I'll show you why in a minute. So let's take a look and see. Did we get rid of CBA, or is it still there? Sometimes, instead of getting rid of it, it gets larger. It means you just move it on top of the blood vessel even more. But most of the time it goes away the first time. Sometimes you have to do it twice. And it looks like we cleaned it up. Okay, so now I'm going to demonstrate to you why you have to push the reset button. So I'm going to take FZ. You don't have FZ right here. Okay, so I'm going to take F3, which is, you got FZ? Okay, so Val, can you blink a few times, please? You can see clear blinks on there, right? EEG signal looks like real EEG signal, right? So what I'm going to do is I'm going to lift the sensor up, put some hair in the way, put it back down. Now FZ has really high impedance. But you can look at it, it looks like it's EEG. But if you blink a few times, please, where are all the blinks gone? Okay, and yet where's its impedance? Its impedance looks like 0. So it's railing. So people go, oh, impedance is fine, it's below 1. It's not. If I hit the power button, I'll reset, and now you'll see it's huge. It's not making any contact. And now you're seeing all the artifacts it's picking up because it's not making any contact. Okay, so now we will lift it up, part the hair, put it down, work it through the hair, press down gently, release. And I'm not going to push the power button yet. So FZ, now the impedance looks good. Can you blink a few times, please, Valerie? Where are the blinks? Impedance looks good. Okay, push the power button. Now the impedance is showing what it's really at. And if you blink a few times, please, there are blinks. Okay, so that's what the power button is doing. It's resetting the amplifiers. Every time you manipulate, you need to adjust it. Okay, so let's get it to where it's good. Okay, so we got to see motion artifacts, we got to see CBA, we got to understand the reset function. The only remaining artifact that is harder to instill in Valerie, because she's such a cool person, is sweat artifact. But there's several ways of instilling sweat artifact. One is heat and exercise and people being hot in their environment. And the other one is stress. I don't want to stress out Valerie, but we'll try. Valerie, you're going to stand up and sing to the people. Okay, so sweat artifacts would look something like that. This is a laughing artifact here, but a sweat artifact would start showing itself up as pop spikes, which are large V's, but this is sweat artifact right there. This is residual sweat artifact. That's what it looks like. It's these large, slow oscillations. And it can happen on all channels, it can happen on a few channels. It's random. Okay, so the way you get rid of sweat artifact is you don't ask the person to sing, and you let them relax, and it takes a little bit of time to get rid of it once it's settled. So you want to try to make sure they're being comfortable from the get-go. One thing to keep in mind is EEG is as non-invasive as it is, we're invading person's private space. we're getting really up close to them and we're touching them. People aren't usually used to that. So give them time to relax after that. If you're seeing that their signal is not this nice and clean, if you're seeing these sweat artifacts, then give them the time to relax, give them time to cool off, and that will clean it up by itself. Again, the symptoms would be, first you'll see V's, which look like blinks, but usually upside down and only on one channel at a time, rather than on all the frontal channels. That's saying, hey, this person's getting hotter and hotter. Check your room temperature, make sure they're not wearing a jacket or they're not too hot. Or if it's stress, it'd be instantaneous. Like you could touch a person and induce huge amounts of stress. So that's how you get rid of those, is eliminate the source. Worst cases, we've had to record sometimes in very hot environments and you don't have access to an AC. Like first time we were at the ISNR conference and we were in a little tent. So what you do is you bring a fan, and I'm not talking about the small fan, I'm talking about the big fans, at least a 12-inch fan. You put it behind the person so that you're not blowing in their eyes and causing them to blink. And you blow in a way that you're not causing their hair also to go in their face, but it will be enough air to cool off the person and get rid of your sweat artifacts. And that's quite efficient and quite fast, and we do not have to worry about the electrical artifacts of the fan with our system. All right, to clean the headset, we're going to grab the alcohol container with 70% isopropanol. We use 70% isopropanol because that is actually very good at dissolving skin fats, and that's what we want to get rid of. So try not to get that too much on your hand because it will be dissolving your skin, painful and dry, dries up your skin. Also, we use 70%, 90% because 90% evaporates too quickly for it to do its purpose, which is disinfection. So we'd like to use 70% isopropanol. That's rubbing alcohol. You can get it at CVS. It's very cheap. Try not to get it mixed in with other compounds. So just 70% isopropanol. We're going to take the brush. We're going to dip the brush into the alcohol container. Lift it up and shake off the excess alcohol. Push the button to start the rotation. We can go fast. And now we're going to go onto each sensor and spend about a second on each sensor. Let the brushes go all the way to the depth of the sensor, to the bottom side of it, to clean it. And then we're going to clean the front foam pad and the sensors in there. And after we go through a foam pad, the alcohol gets absorbed by the foam pad so we can replenish it. We're going to clean the foam pad in between the electrodes. Then we're going to replenish it, shake off the excess, and clean off. Spend about a second on each of the electrodes. And the foam pad. And any surface area that might have come in contact with skin or hair. Do not put alcohol into the connector slots or into the battery slots. For the ear clips, we're going to use an alcohol swab, and we're going to swab the ear clips by opening them, squeezing them against the alcohol swab, and swiping it a few times. Remember to clean both ear clips, and you can clean any surface area that might have come in contact with the skin. When the headset is not in use, it is best to put it this way down on the table, and ideally for long-term storage you're going to store it in its compartment. So at the end of the day you are going to take the supplied pad, you're going to squeeze it all the way and slide it into the headset. So that the arms are extended, and make sure all the arms are sitting flush. You're going to tighten it against the headset all the way, as tight as it can get. You're going to bend the ear clips inwards, and we're going to slide it into its hole, making sure that all sides reach all the way into the bottom. Now your headset is going to be securely stored. We can put all the other components back into the case so that your case contains all the elements you need to record. Remember to turn off the headset. If it was still on, you can press the power button until you see Christmas, which is the green and red LEDs flickering, and you release and now it's off. To know if the headset is off or on, you can press the status button, and if nothing happens, then the headset is off. It is best to store it with the batteries not inside the headset, so we can take off the batteries and store the batteries on the charger if need be. On the top case, you have a mirror for self-donning, you have a through hair tool, you have a tape measure, you have batteries and your Bluetooth device. On the bottom shelf, you've got wired for wired mode operation, you've got a cable extender for the Bluetooth, you've got a charger, you've got a spare tool. If you do lose your tool, contact your sales rep to get another one while you're still using the second one. And you've got a screwdriver for urgent repairs. You've got a spare set of foam pieces and spare set of electrode tips. Every 100 uses, or if the electrodes appear to be wearing off, you need to replace electrode tips. Electrode tips are replaced by using the backside of the through hair tool, inserting it into the electrode tips and rotating it until electrode comes off. Take a new electrode tip, put it in place, and screw it back on until you feel the O-ring start to squeeze, or you hear it squeal, or you feel sufficient tension. And you can do that for all the electrodes. We recommend you change electrode tips every 100 uses. At that same time, you can also change the foam pads. The foam pads are Velcro attached, so you can just peel them off. When positioning the new foam pad, start on one side and go all the way across, and try not to stretch it during application so that all the holes remain aligned at the end. So that's for the back piece. Same can be done for the front piece and the top piece over here. They're all attached by Velcro. The top piece does have a front and a back. The front has the three pieces closest to each other as opposed to the back. Those pieces need to align to the front three sensors. The ear clips can also have their ear sensors replaced, electrodes replaced. Just put your fingernail, put it off, bring the new one, put it back in, press on so that it clicks back in place. The front sensors can also be replaced when the foam pad is peeled off. You can use your fingers and unscrew them with your fingers. Screw them back on. Put the Velcro back in place.